Hi everyone. In today's lesson we're going to talk about graphs of logarithmic functions. So by definition, a logarithmic function is the inverse of an exponential function. Yesterday we talked about inverse. We said inverse is the reflection over the line y equals x. So here's an exponential function, here's the line y equals x, and here's its reflection. So this graph here that I'm highlighting is called a logarithmic function because it's the reflection of this function here, which we call exponential. So, all exponential functions are in the form y equals b to the x. Y equals b to the x, where b is 2. So the inverse would be x equals b to the y. Now how did I get that? Well, I got that because I switched the x and y values. So let's write this down. Switched the x and y values. So again, if an exponential function is in this form, the inverse, when you switch it, will be in that form. Okay? So let's look at the example that I have here. So this graph right here is my exponential function because it goes through the point 0, 1. And let's call this y equals 2 to the x. I'm just going to rewrite this. Y equals 2 to the x. Now, if I were to switch the x and y values, I would get x equals 2 to the y. Now, that's why I put it over here, because this is the inverse of this exponential. X equals 2 to the y. Okay, now x equals 2 to the y is also equivalent to y equals log base 2 of x. Now we're going to talk more about what this really means tomorrow. As far as today, all I want you to get out of this video is that this is an exponential function, and you reflect it over the line y equals x, and you get this logarithmic function. I'm going to talk more about, again, what this means in class. But as far as understanding what I need you to today is just that this is a reflection of this exponential. So I'd like to analyze some things. Let's first talk all about the exponential function. So what is the equation of the asymptote of all exponential functions? So let's see. In this particular example, the asymptote, it's approaching this line. It's approaching the line y equals 0. What is the domain of this function? Well, how wide does it go this way? You should be telling me negative infinity. How wide is it going up this way? You should be saying it's going wide and up forever. So wide would be positive infinity. So my domain would be negative infinity to infinity. Okay, what's the next part of the information that we need? We need the range. So range is how tall this thing is. It starts at 0 and goes all the way up. So the graph from here up is where we have that. So it's not going to hit 0 because it's an asymptote there. So we will just write 0 to infinity. Okay, now let's talk about end behavior. So as x approaches infinity, so x gets bigger and bigger and bigger and bigger, where is y shooting to? So x is getting bigger and bigger and bigger, y is shooting up, so up to infinity. So we would say the part of the end behavior is as x approaches infinity, f of x approaches infinity. Okay, now the second part to the end behavior is as x approaches negative infinity. So let's see. As x gets smaller and smaller and smaller and smaller, what happens to y? Well, look, y is decreasing. It's getting smaller and smaller and smaller and getting closer to 0. Never hits it, but it's getting closer to it. So it's approaching 0. Okay, now what do I mean by this common point? Common point just means what is the point that all exponential functions in this form go through? You should be telling me it goes through this point, 0, 1. All exponentials will go through that point. So that's what I want you to put here for common point. And the last part is, what quadrants does it go in? Well, these are the quadrants in case you didn't remember. Quadrant 1, quadrant 2, here's quadrant 3, and here's quadrant 4. So an exponential graph, this graph right here, uses just quadrants 1 and 2. So we're going to put that here, quadrants 1 and quadrants 2. Okay, now let's analyze the same behavior, but on a logarithmic function. So what is the equation of the asymptote now? So this here is now approaching the y-axis, isn't it? It's getting closer and closer to the y-axis, but it's not quite touching this. So could someone tell me what the equation of this y-axis is? I'll give you a hint. It's x equals something. All vertical lines that go up and down are in the form x equals. So this would be the line x equals 0. So that would be my asymptote. Okay? Y equals 0 is the equation that goes this way. X equals 0 is the equation that goes this way. Okay, what's my domain? How wide does it go? Well, it's going forever wide and to the right, but how wide is it going this way? Well, it's stopping at 0. I mean, it's not going to hit it, but it's going to approach it. So it's from here over. This is what my domain would be. So we would say 0 to infinity. Okay, how about the range now? Well, the range is how tall it goes. It goes forever tall this way and forever short that way. So it's going down forever and it's going up forever. So we say the range goes from negative infinity to positive infinity. Okay, the end behavior works a little different for this. So let's see. As x moves to the right, so as x goes to infinity, y also shoots up to infinity. So that's okay. So as x goes to infinity, f of x also goes to infinity. So now what happens when x is going smaller? X is not ever going to reach negative infinity. You see, it's going like here, and it's never going to pass this. So it's never going to pass the x value of 0. So we actually have to say, as x approaches the asymptote, and the asymptote is here. So we have to say, as x approaches 0, right, what is happening to y? So as x gets smaller and smaller and smaller and approaches this value, where's y going? Y is shooting down. So we say y shoots down to negative infinity. Okay, now let's talk about the common point. So if all exponentials go through this point up here, 0, 1, when I switch the x and the y values, won't I be at this point here, which is 1, 0? So all logarithmic functions should be going through this point, 1, 0. And last but not least, what quadrants does it go through? A logarithmic function will go through quadrants 1 and quadrants 4. Okay, so let's just write that in, quadrant 1 and quadrant 4. All right, let's analyze what just happened here. Do you notice that the common point, 0 and 1, in an exponential, for the logarithmic, it's 1, 0. So how do I get that? Switch the x and the y. Look at the domain and range. Domain is x values, range is y values. So the range, which is y, became the x for my domain here, and the x for the domain became the range for here. So it looks like everything in exponential functions is just flipping over for everything in a logarithmic function. I know this was a lot to digest today, so why don't you see if you can look it over, analyze it a little bit more, and come in tomorrow with questions. This is a big new thing for everyone, so it's okay that you don't get it right away. Leave the back of this worksheet blank. We're going to go over that tomorrow. All right, see you all tomorrow.